In this video, we're going to look at the first of our functions within our mathematics library. Now, the function we're going to look at is the absolute value. So let's quickly have a look and see how this works. Now, if we have the number -5, then when we find the absolute value of -5, it'll give us the number +5. And if we have the absolute value of the number +5, it just leaves it as the value +5. So all the absolute value does is it takes all of our negative numbers and makes them positive. And it takes all of the positive numbers and leaves them positive. Now, whenever you see this written down, you'll see it sometimes with the two lines and the number in between. And we just read this as the absolute value of -5 equals the number 5. And you'll sometimes see it written as ABS and the number inside the brackets. So now we know what the function looks like, let's go ahead and we'll see how we're going to generate this function. So I've got two pieces of code here. The one on the right is the calling function, and the one on the left is the subroutine. So let's first of all talk through the calling function. We're going to take the number that we want to find the absolute value of, and we'll call that number x. And we will push that number onto the stack. Now, once the number's on the stack, we can jump to the subroutine, which is called math ABS. Now you can see here that math ABS is just an address. So it's just the address that we have to go to in the ROM in order to run the subroutine. And you can see that as 0 × 350. So at this point here, we jump over to the 0 × 350, which is this subroutine. But remember, whenever we jump to the subroutine, it automatically puts the return address onto the stack. So at this point here, we're going to have two values on the stack. We're going to have the x value, and then we're going to have the return address. So whenever we get into this subroutine and we pop the values off the stack, it's going to pop the return address off first, and then it's going to pop the value of x off. So let's jump in at this point here, jump over to the actual subroutine. So we're going to pop the return address. Now when we pop it off, we have to put it somewhere. So we can put it in a local variable within this subroutine. So this local variable is called return address. And you can see here I've set it up here as the return address here is a defined constant. So return address, initially I initialize it to a value of 0. So the return address is going to be at position 0 × 8151. Okay, so that the save will be at 8150 and return address will be the next one, 8151. Now once we've popped that value off, we can then pop off the value for the x, and again we can save it as a local variable in this variable save x, and you can see here it's the variable save x is at the address 0 × 8150, and again I've set that up initially as a value of 0. So that's us past the value that we want to work out the absolute value of into the subroutine, and we've passed it by value using the stack. Now what we want to do is we want to take all the numbers that are less than 0, that's all the negative numbers, and make them all positive. And then we want to take all the positive numbers and just leave them exactly as they were, so we do nothing. So we're going to have to find all of the negative numbers. So first of all, what we can do is we can compare the value save x with the number 0. Now if the value, this is read, if jump if a is greater than, now a really means this value here, so this is the a value and the save x is going to be a b value. So it jumps if a is greater than to this convert. So really it's just saying if this number 0 is greater than the number save x, then the number save x must be negative. Okay, so at that point there we jump down here to the convert. Now at the convert we want to change all the negative numbers into positive numbers. Now there's a quick and easy way of doing that in 2's complement arithmetic. All we need to do is add the value 2 to the power, subtract the value 2 to the power 16. When we subtract the value 2 to the power 16, we're going to get the positive number. And we can save that into save x. So we can do the subtraction and save the answer straight into save x. And then this is going to have the answer to the absolute value. So we want to push the answer back onto the stack. So we push save x back onto the stack. And then we jump to the address which is given in return address. Okay, so the return address, again, you know, it's was within the stack and we took it off the stack, so we've got it here and we can return to that point. So at this point here we just jump back to the return address, which is just after the subroutine, which is this pop value. So at that point the stack's got the answer here in save x, and we just pop it off the stack and we can put it wherever we want to. Now this instance here, I've put it in a variable called mod x. You could, if you want, just return it straight back to the variable x. It's up to you. It depends on your own programming and what you're doing. So you can see here the mod x, I've actually got it down here as an address, and it's going to be 8201. And again, that's initialized originally to a value of 0. So that's how we find that answer. Now, if it isn't a negative number, then we don't bother doing anything. We just take the original value, save x, and we push it straight back onto the stack. And then when we've pushed it straight back on the stack, we jump to the return address, which jumps back up to here. And again, we can pop that value off and we can save it in mod x. So that's the basis of our subroutine. Now what I've done is I've ran this, okay, or I have assembled it, and then I've taken the assemble code and I've placed the assemble code at 0 cross 350 within the ROM. I'll actually show you that here. So here's the ROM here. When I go to 0350, I think you can just about see it. Then you can see here 0350, we have the code. So this is the code for our absolute value. Now, once we've generated that, we can then generate the code for our actual example. So the actual example we've got here is this one here. So this is our actual example. So we can put the number -5 in and we should get the number 5 out. So the number -5 will go into memory location 0 cross 8200, and then the number +5 will come out in the next memory location, okay, which will be 8201. So what I'll do is I'll go ahead and I'll put these values in. So if I begin, and we'll put the program in first. So that's our program in. Now we can run through this and we'll see it actually working. Now it should run through pretty quickly. It's just a short program. You'll see some of the numbers here appearing. So that's it finished. I'll stop it running, and that's it stopped. We'll drop in, and if I come into the contents here, you can see that at address 8200 we have the number FFFB. So FFFB in 2's complement, that's actually -5. And you can see the next memory location has got a value of 5. Okay, so we've found the absolute value of -5 and it's given us the number 5. So that's a nice little start into a mathematics library. We won't be doing any more mathematical functions here within this Design a CPU 2 course. This is just as to show you how we're going to work our way forward. Whenever we start in the Design a CPU 3 course, we will start off by adding lots more mathematical functions and also graphical functions. So we will build up a mathematics library, and we can use that mathematics library within a graphics library. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.